What is the coefficient on the third term of the standard expansion of the expression x minus 4y quantity to the fifth power? Well, our first term is going to have some sort of coefficient, followed by our first term, x to the fifth, times negative 4y to the 0, plus our second term is going to have a coefficient, and then we're going to have x to the fourth times negative 4y to the first, plus another coefficient with our first term x raised to the third power and the negative 4y squared, and so on. Since the question only asks for the coefficient of our third term, we don't need to write out all of them in this question. Now we have to figure out what the blank coefficients are going to be. If you recall, the expansion of binomials comes from Pascal's triangle, which is 1, and then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then we also have a 1, 5, a 10, 10, 5, 1, where the top row represents the binomial a plus b to the 0 power. The second one represents a plus b to the first power, and so on. So this would be squared, cubed to the fourth to the fifth. So because we're doing x minus 4y as our binomial to the fifth power, we're going to be using this row of coefficients. So therefore, our first blank space is going to be filled with a 1, second blank space is being filled with a 5, and the third blank space is being filled with a 10. Now, in order to determine the final coefficient of our third term, we need to multiply and evaluate the algebraic expressions here. So we have for this third term, I'm going to erase Pascal's triangle so we have more room to write. So we need to evaluate this third one. So we have the 10 x cubed, and then negative 4 quantity squared is 16. And then we have a y squared, and then I can multiply the 10 and the 16 together to get 160. So therefore, the coefficient of our third term is going to be d, 160. Bring this all the way out so you can see the whole expansion. There we go.